All right. So we're going to start our new unit. This is another talk about probability, statistical analysis. You'll see. So what we're trying to understand in this unit is when we get given probability, which is basically like a percentage or odds. Okay, there's like a 30% chance of rain tomorrow, whatever. We need to be able to understand stuff about this number, but also how to get that number in the first place. So a lot of situations where you use probability are like gambling. What are your odds of winning when you're playing cards or playing a game or whatever? Medicine. So we get new medicine or techniques. What's the percentage odds that it's going to help people, or how much is going to help people? When we predict the weather, is it going to rain? How much is it going to rain? Whatever. Or any kind of predictions like business, like how much money are we going to make? How much businesses are going to close based on stuff happening? Whatever. Okay. All of these things are related to probability and stats. So when we're doing this, we need to talk about how accurate and precise these kind of collections of data are so that we can understand and decide, do we want to trust these predictions? So whenever we want to make predictions about stuff, we need to do experiments. Okay? We can't go out and know the weather tomorrow because we can't see the future. So what we have to do is do an experiment that is like tomorrow so that we can make a good guess about what will happen. So these kind of experiments, we need to figure out, are they accurate and precise? So sometimes when we get results, they will be helpful and useful. Sometimes they'll be misleading. So that's where you get someone who says like, oh yeah, I know what's going to happen tomorrow. It's going to be like this. And they think they know what's happening, but they're actually just making you think the wrong thing. So there's 3 words we need to know. Okay, accuracy, precision, and degree of accuracy or precision. So accuracy is basically if you're making a guess, how close is it to reality? So like, is it right? Okay, that's the key thing. And basically accuracy boils down to, are you making mistakes? Sometimes the mistakes are hard to notice, and we'll see some examples later on, but mistakes can be something like asking how fast people type and whether or not they're using a Mac or a PC. So if you did everyone on a PC, they might have different results than if they did a Mac. So when you apply a guess to a different situation, that is inaccurate. Precision is when you do experiments, how precise are your results? So if we ask 100 people to do an experiment and they all get very, very similar results, that's precise. If you get results that are all over the place and very different, the results aren't very precise. The degree of accuracy, basically, when you're measuring answers, how many decimal places do you use? So for example, if I measure how tall are you, if everyone just measured in centimeters, that would be kind of like a low degree of accuracy. But if people measured their height to like 5 decimal places, so like, oh, I'm 156.253 centimeters, whatever, that would be a higher degree of accuracy because I'm using more decimal places. So let's do an example. Okay, so let's say they made some new medicine and we want to decide, we want to figure out how good is it? Is it going to actually help people? So let's say that the truth. Now, a lot of times when they make new medicine, they don't actually know 100% what's going to happen. But let's just say in this situation, the pain people have will be reduced by 13.145%, but we don't know that. We did an experiment where we asked a bunch of people to take the medicine and say how much their pain was reduced by. These were the results. So as you can see, if we found like the average or whatever, a lot of these results are pretty similar. So these results are fairly accurate. Okay, but they're not super precise because you have a lot of people that are all over the place. If these people weren't included and it was just this, I would say this is decently precise as well. Okay, now the thing with accuracy is there's a lot of factors that can influence accuracy. This is where you gotta critically think about what you know in real life and what kind of stuff we need to consider. So for example, we don't know who these people are. Let's say all of them were 13 years old, lived in Vancouver, and yeah, okay, they're all 13-year-olds in Vancouver. Do you think that these results would be very similar to a 70-year-old person living in like London, England? Not necessarily, right? It's going to be different based on what's going on in different places and how old they are and different factors. So in that situation, it would not be accurate. But you need to decide if we're dealing with another 13-year-old in Vancouver, these results probably would be pretty accurate because it's a similar situation. Let's do another example. How good is Mr. K at soccer? Okay, so in order to answer this question, we need to like do an experiment. So I'm going to make him shoot in a net. So let's say I have my net okay? And let's say I did like 100 shots, okay? Let's say I made 80% of the shots. That would mean I could make a prediction Mr. K is going to make 80% of his shots in a game, okay? Now, if in real life my shooting percentage is actually like 30% in a game, that is not accurate. Now, we got to figure out why isn't it accurate. Now, let's just say the reason I do so bad is because of pressure. You know, when you're playing the game, it's kind of scary. There's defenders, all this stuff. When I did the experiment, I was just standing there shooting in an empty net. That is not really like real life. So that is an inaccurate study. Now, however, if what I did was I measured my numbers over a bunch of games and I got numbers, that would maybe be a more accurate study. Now, the other thing with precision, this making or not making doesn't really measure precision. But if we wanted to see where I shot on the net, let's say when I shot, I always shot in these spots. Okay? That's fairly precise. Most of the dots are in basically the same spot. So you could say Mr. K is going to score within that spot. And the measurement, the experiments I did were very precise because look, all of the shots were like within the same basic area of the net. Whereas if you did a different player and you measured, he could also make 80%, but his numbers could be like that. In which case, you wouldn't be able to give a very precise guess about where he will shoot, but you could give an overall percentage of how often he will score. So these kind of situations, trying to understand what accuracy and precision mean, can be helpful because when you're measuring, is this a good study? Do I trust these numbers? That is the core thing of what we're trying to decide. Do I trust these numbers? What is included? What is not included? Is it accurate? Is it precise? Is it not? All right.